Okay. Yeah, we're live.
2 minutes early. No, 1 minute early.
That's right. There's a delay between, us and the real world out there. So
We're working a minute faster than everybody else.
looks like Captain Bratzett's here with us saying hi. We say hi back.
I think that's hype.
Oh, hype.
Yeah.
Oh, got it. Wait a minute. Are you saying that this is overhyped?
No.
Uh, sorry. We tell you what, Edmar's not here. Edmar's out taking a break. And so I better do the right thing here and let's talk a little bit about um, what's going on at NVIDIA right now. And that is GTC is coming up. Let me see, I'm getting the link. So if you want to learn about everything that's going on at NVIDIA, then you got to check out GTC. Boom. GTC is what does that stand for, GTC?
Graphical Technical Conference
Graphical Technical Conference.
or Graphical Technology Conference. Pretty sure it's one of those two.
And it's our main, we do it twice a year. And we're going to talk about all the cool stuff coming from NVIDIA. And it's free. And we're going to be sharing some really cool stuff ourselves. It's top secret right now, but we're working really hard to get ready. And yeah, I can't wait to show everyone what we've been working on. But like I said, top secret until GTC. So
Exciting stuff. Yeah, there's definitely a lot of things. Please, I would recommend always registering and starting filling up your schedule as soon as you can because there's some very interesting classes going on. Either it's DLI or some speakers kind of talking, and obviously the keynote. Don't miss the keynote. That's like the biggest one.
well, and we're doing a whole bunch of Omniverse training sessions, hands-on training sessions. We'll be in
Yep.
some of those as TAs. Jen is teaching one. What's the session you're teaching?
USD fundamentals on USD.
Cool.
Yeah.
Yeah. So if you want some hands-on training sessions, join us at GTC. If you want to know all the coolest stuff, check out the all the cool hot new stuff. Check out the keynote, and we look forward to it. We've been working hard, getting ready, so everybody has. Um, all right. So if you look at my screen, you will see the crank slider mechanism. Um, we added the last joint last time and it didn't quite work. So I took a step back and let's see how it looks. Yeah, I mean, it's looking like a pretty solid mechanism at the moment. Everything looks lined up. We've got the slider in the crank. Let's try adding this last joint and let's see if we get that same problem that we had last week. So I'm going to select these two parts and I'm going to go right click, create. Oh, didn't matter the order this time because if you look, they have the same coordinate. They have the same coordinates at 0. So they're lined up already, which makes me happy. So let's select those two. It's going to put the joint into the link. How do I feel about that? Wait, I don't want the link. Oh, that's the wrong one. I wonder if that's what I did. I want the ground in the link. Let's make sure those are lined up. Yeah, they're both at 0, 0, 0. You know what would be a great extension?
But
Something that just told me the global position and of if I just selected this because this has got my local coordinates, right? Like if I select this, it's got this translation and stuff from from that its parent's position. So if you go down a few layers, like you could have 3, 4, 5, 6 transforms, and it gets a little confusing. And I wonder if it'd be handy if you could if you could just pick something down low and it could tell you its global coordinates, and if you could even set its global coordinates, then it would move the local transforms for you. That'd be nice. Just a thought. And oh dear, we've got a bad pun from Zia Ideas, so of course I have to share it. All time to get cranking. It is. Oh dear. Oh dear. All right. I'm gonna add this to the get the crank. Oh, get the slider, and I'm gonna select the ground, and we're gonna create a physics joint, prismatic joint. There it is. It's there in the ground. Let's take it to the joints first. Let's rename it.
You're working in the right layer, right?
Oh dear, I didn't even check.
Oh.
Probably not.
I didn't know if you were still doing them. I assume so, right?
Yeah. That's a good reminder. I forget after a week. It's been a long week.
Oh yeah.
Sliders to the ground. We are in the right layer.
Nice.
Yeah, and that's one thing is if you only edit an item in that layer, you could drag its deltas to the right layer and drag and drop those. But the problem is that would only work if all of the edits on that object, you need to drag all of them, I think. And so it's worth looking into. Just curious. Delete delta. It'd be kind of cool if you could inspect. See, I have all these ideas, right? Like, I wonder if you could write an extension that lets you inspect a delta and see all the changes, and even select specific properties and move them to a different layer. Because right now I have to move all of the deltas for that item to, I can only move the entire delta, but it would be nice if I could almost like staging in Git, where you could maybe just select certain deltas or part of the delta and just move part of the delta.
Now, when you say part of the delta, what are you referring to?
Yeah, good question. So, let's see here. Let's save it. Well, first of all, let's see how this works.
Before breaking it.
What? Didn't it work this time? I must have picked what I think I did? I think that when I created that Revolute, I picked the link and the ground or something like that. So I just couldn't possibly keep those aligned.
Makes sense.
And I've got no friction, so it's just going and going and going. Yeah. So there you go. It's working. I think that's the problem. Just spaced it last time, so I don't know what to say. Let's see here. Let's see. Joints. Should we just talk about those deltas for a minute?
Yeah.
And just layers, because what we were gonna do is debug this, but it just worked. So, boom. Should we let's talk about layers just a little bit, and then we'll come back and add a driver to that joint so that it's a driving mechanism. All right. First of all, let's talk about deltas. Let's save this, and let's create a new scene.
Yeah, not mess with that one.
No, that one is like gold. I'm gonna create I always create a ground plane just because it's just a nice white plane even. All right. Does that bring it into the layer? No, but we'll just do it. I know this isn't how we would actually work, but let's bring this crank slider in as a sublayer.
Yeah, when you drag it in like that, it adds it either as a payload or a reference.
Yeah, which is actually not, which is actually a good way to work.
Mhm.
But here, just a moment. Alrighty. Alrighty, let's see here. Just had to close my office door. Okay, so check it out. If we right click and set this to the authoring layer, it will actually um, edit this, the original USD layer. Okay. I'm just trying to think if we want to do this or not. Yeah, we just want to save it. So we're gonna. So if I edit this, and let's take a look. Are we in? We're not in code. Let me think about how to show this to you.
So if we like, let's say, edit the ground plane, does a delta end up getting shown in this authoring layer that we're in right now?
Yeah, that's a good way to do it. So we can take this ground plane and translate it. What we'll see here is that delta is right there in the ground plane. And what we
Okay.
can do is we can just drag that to the root layer. So now I've moved those edits to the root layer instead of having
Okay.
them in the slider crank mechanism.
I see. So then if like let's say you move the base of the crank slider.
But let's say there's this. Let's say I did this though.
Okay.
Let's say I move this. Oh shoot! Now it didn't.
We moved the ground plane again.
Well, it won't let me because it's now it's saying it's overridden in the root layer.
Oh.
Interesting. Let's go with a better example. And I'm kind of I'm going to start from scratch here because I don't want to actually edit that mechanism. Let's just bring in an asset like a tree or something. So create physics ground plane. Let's bring in a tree. Give it a minute to load the tree. That's a good looking tree. Is that something that what's his name? It's got a happy little tree.
Oh, Bob Ross.
Bob Ross. All right, so we've got, let's say, like let's call it park, and let's go to materials. Look at that pretty park. Oh heavens, that is wonderful. And then we're just gonna save this. Let's do it right here as park. Okay, let's say I painstakingly made this nice park. And and we'll talk about this here. Jia asks, what is the difference between a payload and a reference? Yeah.
Ooh. Ooh. Give me 1 second and I will get
Let's,
you that answer.
well, I know the answer.
Oh, you do? Between a payload and a reference?
Oh yeah, yeah,
Okay.
absolutely. So I'll show you. So now let's say that I've made this wonderful park, and Jen wants to use it, but I'm like, hey, Jen, don't mess up my park.
Ooh.
So Jen, we're making a new scene for Jen, and she's gonna she wants to take that park, and so really the right way to do this is we're gonna go to here, and we're gonna double click on that park. And that's going to bring it in. There we go. Just a second. Well, that brought everything in, didn't it? Well, that's not what we want. Wow, I'm struggling. All right, let's start from scratch here. And then let's just add a right click, add a reference. So you can add a reference or a payload. So let's add a reference. Actually, first, this is going to create it inside of whatever transform we create. So we don't put it underneath world. So let's actually create a transform first. I'm going to name it park. And we can add a reference now. Let's do that first. And then if we can come to right here to park. There we go. So now we have a reference named park. And if you scroll through the properties, you can see the reference right here. Okay? And in the reference, this is really cool. You can see the path to the asset. I don't know what you'd use the prim path for. But
so prim path is to kind of say what is essentially the default prim, or the so like in when you make a new scene, your world is your default prim.
yeah.
So for this what are we looking at, the park? So the park, that is considered the default prim. Otherwise it would have like the path. So like I think if you select like something underneath it and then look at it, it should have its path relative to the default.
So could we just grab the American Beach out of the park with that? Is that what it would do? It would just like go down to.
Yeah, so if you just click on one and then see what that prim path one is.
I just broke it. So it didn't load anything now for that reference. Oh dear.
Yeah, because it's trying to find the something else, and if there's not something else, then it. So now it's using the default.
So I can say like, let's just pick the American Beach. Copy to clipboard. Let's just mess with this. Do we change that default?
Mm-hmm.
It didn't work.
Oh.
So I'm not sure what that prim path does.
All right, I misunderstood that then.
That's okay. But we'll say that for another time. It's okay that we don't understand it, because the question right now is, what is the difference between the reference and a payload? Now, but just also when you bring in a reference, you'll notice right here, there are these checkpoints. You can choose. So every time you save USD scene, it creates a checkpoint on the Nucleus server. And so you can actually grab an older version of USD, and even if the original owner, edits that file, you won't get those edits unless you change the version in here. If it's set to head, it will just always have the latest. So that's a reference for you. Let's delete this reference. Let's add a payload instead. We're going to add the same thing as a payload. You'll notice it looks the same, and it looks the same here. The only difference is this little checkbox. If I uncheck this, then the park will still be in my scene, but it doesn't actually load the asset. And so if you're working with huge scenes and you want all of your assets to show up in the scene as in the tree, but it's getting a little too heavy for you, and payloads are a great option because you can just choose not to load some of the payloads. And that just helps you with your resources. But besides that checkbox, they work the same. So I would probably favor payloads because at least, why not?
Yeah, payloads. I mean, they're all part of the composition arc of what USD is. References will be stronger than payloads. So, like, if you have um, the same scenes, right, but one is referenced as a reference and the other one's referenced as a payload, the reference is going to take preference over the payload.
Oh, yeah.
Yeah, payloads are usually just a weaker form of reference.
So if I add a reference to the same thing, what happens?
It'll probably override your payload.
Oh, no. It's just messed up. I probably shouldn't have done that. If I delete this now. Oh, now it's all messed up. Yeah, I messed it up for sure. It won't let me delete the payload. So don't do that. Don't do that. Great question. Zia asks, is unchecking the payload different from toggling the visibility? Yeah, because if you toggle the visibility, it's still loading the asset. It's just not rendering it. So toggling the visibility, I think, would gain you some performance. But if you uncheck it, it just doesn't load it into memory at all. So so unchecking the payload saves even more resources than toggling visibility. And okay, and then also asks, what was the analogy for Git staging versus a transform tree? Great question. Maybe Git analogies aren't the best analogy because not everyone uses Git. Let's see here. Let me think about it. So with staging in Git, basically if you're writing code and you're using Git, what you can do is you can go line by line and say, oh, like, let's say you added 2 features to your code at once and you haven't checked your code into Git. What you can do by staging is you can select specific lines and say, well, let's say you added a button and a checkbox to your UI. You could just highlight all the lines that had to do with adding the button. You could stage those and then commit those. And then you could go down and just stage the checkbox lines and commit those. And that would give you 2 commits. You can kind of separate your commits so that each commit is kind of associated with a specific edit or a specific task you were doing. It's just a way to, if you're just coding away and do more than one thing, it's a way to kind of organize your work so that people down the line can say, okay, like here they were adding a button, here they were adding a checkbox, and you can kind of organize what you were doing. And let's just get into, and I'm not the expert in this. I would say take this next part as something to whet your curiosity so that you'll go out and check out Dave Tyner's sessions because he's like the pro with layers and these workflows. I've just been learning a little bit. And so let's say, so the thing about the way to handle these sublayers is you kind of want to go by task, right? So let's say that, let's see here. Let's say that I want to have all different, let's say that for my job, I create scenes with bouncing balls all the time. Okay. That's just I just do that all the time. So what I can do is I can use sublayers. Let's make sure I have a fresh new scene. And let's say I just kind of have this set up that I always do. Let's create let's just even do like a gummy one. I do these gummy ones all the time because they're so fun. Okay, so I've got a sphere. And I want to make my sphere bounce. Let's say this is a big one. A big sphere, and it's at this height up here. I want to make this this sphere bounce, and I do make bouncy or jello balls all the time. So what I'm going to do is I'm going to right click to this root layer. I'm going to create sublayer and create sublayer. Oh, I've got to give it a name. Let's go back to my thing here. We're going to name it Jello Ball Rigging. No, we don't want to move stuff to this Jello Ball Rigging. So now what I'm going to do, I'm going to set this to the authoring layer. I'm going to do all the tasks that have to do with rigging a Jello ball. So I'm going to create a physics ground plane. Right? And then I'm going to go and going to go to this sphere. I'm going to add physics deformable body. And let's go to that deformable body. And let's make the resolution like 25. And so now when we run, we've got a Jello ball, right?
I can play with that all day.
Yeah, but here's what's cool. So now I have this Jello ball rigging layer, and I made that ground plane, and I added the deformable body to that sphere in that ground plane. And so if I go to my stage and I just have, this is called sphere, great. Let's save this edit layer. This is the whole scene, like, so I'll call big Jello ball. So now what I can do is I can go file new. I have a brand new scene. I go create mesh sphere. I'm just gonna leave it that size, drag it up a bit. Now check it out. I gave it the same path on purpose. So now I can insert sublayer. And remember how those deltas were in that Jello ball rigging layer? So now
The one that had like world and stuff?
if I open that scene, it's going to do all those deltas to this scene now.
Oh, interesting.
It added the ground plane, and it found the prim with the path sphere, and it should have added Jello to it. So it's like a macro, right? It just went in. Yeah. So all that rigging. So if you have like let's say you want to rig a person, right, to do some animation, and you could create multiple scenes where they're all the same. Man, it's kind of cool, right? So yeah, so these sublayers are kind of like, I think I'm starting to think of them almost like macros. Yeah.
So in this case, the delta went onto the sphere for that USD file, whereas before it wasn't.
Yeah, well, no, it was. So let's save this one. File, save. Um, small Jello ball. Let's open that big Jello ball, right?
Uh-huh.
If you look at the Jello ball rigging, it's got the world. I've got added the ground plane. Is added deltas to that sphere.
Oh, so the sphere was already added to the root layer.
Exactly. Yeah.
Okay.
So it's looking for that sphere and adding deltas to it, just editing in that sphere.
Okay, and then when you drop it into a new scene that has those items,
It'll totally do that.
So what if you didn't have a sphere in the scene? Would it still have deltas or would it not?
Let's just find out. Insert sublayer. Jello ball rigging, open. Yeah, there's a sphere, but if we go to our stage, it couldn't find a sphere, so it just ignored it. Oh, look at that. There's the sphere transform, and it's added a sphere transform with a deformable body to it.
Okay, so it only saves that particular property.
Yeah, the deltas don't have the whole thing. They just have whatever you've changed. So
Okay.
I wonder if I create mesh sphere now, what happens? Okay, yeah, it's kind of didn't work right because I didn't have the sphere first, right?
Mm-hmm.
But then if I delete, if I remove this, let's see, remove layer, yeah, go to my stage, create mesh sphere, drag it up, make it tiny. Oh, maybe not that tiny.
No, make it that tiny. Make it real tiny.
And I can I don't know, let's go, ooh, that's kind of metallic grass. I think we want glass. Glass is the best color for gummy stuff. Let's do green glass.
When would you ever use metallic grass?
I don't know, right? We could even, let's see. Well, it doesn't have physics yet. That's okay. What else could we do this? We translated it. We could, geometry mesh. I was wondering if I can give it initial velocities. That'd be kind of cool, but velocities. We'll just not mess up that yet. So now I've got the sphere. Now that I've got the sphere in the world, I can insert that sublayer, jello ball rigging, and those deltas will be applied to that sphere. Boom, we've got a jello ball.
Nice. Here's a question. So we take the deltas of one sublayer and apply them as deltas for another sublayer?
Think of it like a workflow. So in this case, if whatever we want to happen to this sphere. So let's think of it this way, okay? I'm gonna delete this green grass. Let's say we want all of our spheres to be green glass, because that's Jello, right? It's green glass. So I'm gonna come back to this Jello rigging, and I'm going to set it as the authoring layer. And whatever we want, changes we want to happen, whenever we do a Jello ball, we'll do in this layer as a kind of a workflow. So let's go ahead and apply the glass now. And so it's added the green glass to our Jello ball rigging layer. And if we look at this delta, we can see what it's done. Or no, we can't. We can just see the state of the sphere. Yeah, that's one challenge. Is I don't know how to just look at a delta in here and see only what's done to that. So let me show you how this works, and then we're going to switch to code, and I'm going to show you the deltas, what they look like, because that does really help. I think help me understand what a delta is.
It's kind of similar to what we tried doing before, right? Was bringing it in without having a sphere, and it only showed the deformable body on it.
Yeah. Yes. So I saved the Jello ball rigging layer. I haven't even saved this scene, which is okay. I don't think we need it. Let's go to the small ball one now. And we're not going to save this stage because it's just a new Jello ball stage. But when we open this other one, it's now glass. We didn't do that in this stage. And let's go to the big ball. It's just off to the side. It's green glass. So because we brought in this sublayer, we edited this sublayer in a different scene. So it kind of modified our workflow. And any scene that uses that sublayer will have those deltas in it. Cool, right?
Okay,
kind of,
my mind is blown.
yeah.
I had to think there. I was like, wait a minute.
I'm thinking more and more. I'm thinking of the Jello ball rigging, like as these sublayers. As think of them as macros. So if there's something you want to do, like whenever you're doing a certain task, think of it as like, well, what do I do every time, and build those into your sublayer. So when you bring that sublayer in, it applies the same operations, the same edits to everything of that type, or
Yeah, so when you're in industry, how could this be helpful?
Well, if you are like the expert in glass balls, then you can come up with a great, or Jello balls, you can come up with a great Jello ball sublayer. And whenever somebody asks you to rig up a Jello ball, you just like drag your sublayer in, and boom, it's all rigged.
Mm-hmm.
Yeah,
Okay. What about if there was like multiple people that were all working in there? Could they all work in their own sub layers as well?
sure. So if you have your own tasks, yeah, you can have
Mm-hmm.
different sublayers. Those could all be like, it gets it's quite a deep rabbit hole if you think about it, because
Mm-hmm.
I could make this my alive layer, and then you and I could collaborate on just the Jello rigging, right? Just that portion of the rigging. But let's switch apps to code, because there's a really nice tool. Let me just save this stage. No, and
It's
let's.
not worthy to be saved.
We're just all I did was simulate it.
Uh, but simulations are important, no?
And we'll just change the position of it, and then I don't know what it actually edited there. All right. Alrighty. So let's go to Exchange and go to one of these scenes, okay? Let's open up the big Jello ball scene, and let's right click. So in code, you can right click. What is my? It's kind of going off the bottom. Right click, and we want to click on edit, I think. And this actually shows us the text of this scene.
Mm.
Okay, so let's look at the USDA, or the
It's the USDA.
yeah. Sorry, Captain Brought. We're asking, do you know a bowl feeder with vibration? Would it be possible to simulate inside of Omniverse? And I don't. Is that like a? Yeah, I don't know what that is. Sorry, but I'd be curious to try. Let's see here. Custom layer data.
Oh.
And so you can see, like, let's get to the good stuff. Yeah, default prim is world. There's that. Remember that default prim we were looking at? I wonder if you just renamed that default prim, if it would.
Mm-hmm.
Yeah, that must be it. You could name that something else,
Mm-hmm.
which I wouldn't really do. Now check it out. Sub layers. It says that we're using this Jello ball rigging sublayer. And then if you look at the sphere, we've got this sphere defined. So we've got the transform. Instead of that, we've got a sphere. Here we have a distant light, and that's it. It doesn't. This is our big Jello ball scene. It doesn't have the glass material. It doesn't have the deformable body. It doesn't have the physics ground plane. It doesn't have any of that. All it says is that we've got this sublayer. So all of that stuff is in that sublayer. Okay. So now let's look at that layer. Finish editing.
think something also to keep in mind is the order of your sublayers matters, right? So
Yeah.
if you brought in, like, let's say your little Jello one and your big Jello one, I'm pretty sure if the big Jello one was the first sublayer, that would take precedence over the little one.
Yeah, or I think more if I had two like Jello rigging ones, and one of them had a rigid body applied to it, one of them had a deformable body, or one of them had green glass, one had blue glass. I think whichever one's higher would take precedence. Yeah, I think you're right. So here's our rigging scene. So here's it overrides world. It'll add a ground plane to the world, to your world transform, and then it will add a collision mesh and a collision plane. That's our physics ground plane, and then it overrides sphere. And what does it do? It adds a material binding to it of glass, and then adds a deformable body to it. Woo! No joke.
Oh, yeah.
We're gonna collapse that one here, I think. Oh, we can't. We're gonna scroll way past. Okay, that's a lot of.
Yeah, there's a lot of points.
And those are the collision vertices. And then, yeah, here's that deformable body's got a lot of data. So that's adding the deformable body to it. All that stuff. Okay. Oh, I'm gonna get myself sick. Scrolling through that long list. Here we go.
Yeah. I found the feeder. I didn't realize that this is what that was.
Oh, let's check it out. I was wondering if it was like a shaker that like shakes things through to somewhere else, but then there's that green glass. And so if you look, that this delta, it just has, so the delta has like that ground plane. It has and it has the materials, and they're actually defined in here. But then it also overrides the sphere and adds the deformable body to it. But I just want you to notice that override in the sublayer doesn't have all of the information for the sphere. It just has the properties that it overrides. It overwrites, and it'll overwrite those properties in the original sphere when you bring in that sublayer. So, all right, we've got a video.
Yeah, but before that, pop quiz. If we have a chess set, pieces can be arranged on the board, lit and textured. If the pieces are on a sublayer, the vertices for the chess pieces can be modified without destroying the main scene up the tree or the layer tree.
Yeah, I'm reading that again. Yeah. So let me think of that. So one way, let's say you wanted to, not animate, but like let's say you were always doing chess, like different famous chess end games or something like that, like the last move of a chess game. What you could do is you could have first make a chess scene that has all of those chess pieces in it, and then you could take that scene, and then you could like you could sublayers. You could make a sublayer for the different moves for each end game, or you could. There's a lot of ways you could do it. You could actually just use that for checkpoints. You could like. You could create the chessboard with the chess pieces and all the lighting, and then you could save that as a checkpoint. And you can move all the pieces to a given end game, save that as checkpoint. You can move into a different end game and set that as a checkpoint. So you could have checkpoints for each stage. Or if you want to do different chess sets, but they always had similar lighting, you could do that lighting as a sublayer, and then apply that same lighting to all of your different chessboards. There's just a lot of different ways you can work.
This is a good one.
But
swapping out the different styles.
I'm all right here. So, let's look at this feeder here. Here we go.
I totally forgot this exists.
Oh, interesting.
So essentially, it's like moving them through
Yeah,
vibrations.
and there's maybe some angle to it.
Yeah.
Oh, that's kind of cool. I could watch these all day. I want this to be like my desktop background. And yeah, okay, cool. Uh, yeah.
Can we make that an Omniverse?
I don't know. That's
Uh,
yeah. That's it. I hope you'll try. That'd be so cool. Let's go back to this chessboard thing, right? Let's say that you wanted to have like a whole bunch of combinations, right? There's like 10 different chess sets you wanted to simulate because they all have the same structure, right? And you wanted to simulate those across 10 different end games to make 100 different configurations, right? So you've got the wood chess set with endgame one, and you've got the glass chess set in endgame one, et cetera, et cetera. What you could do is you could first, so create your first chess set, and then you could create like your, you could then create your 10 different looks. Each has a different sublayer, and then you could move your positions as a different, like you call that your looks sublayer, like look 1 through 10. And then you could make your endgame sublayers, endgames 1 through 10. But then you could like make 100 chess sets that were just generic, just make 100 copies, and then apply those two combinations of your endgame and your look, and it would give you those 100 unique or 100 different combinations. Am I making sense? Does
a
that make
little bit.
Yeah. Um, Zia says Isaac Sim has force fields, maybe akin to vibrations. The problem with force fields is they'll apply in the same direction across the whole scene. I think you could probably just, I mean, you look at our crank slider. I bet you could just like make a mechanism that vibrates something. I just wonder what would happen, right? Because if you like, I mean, in theory, let's see. Let's open up the crank slider. I told you we were going to drive that, and we've got 13 minutes left anyway. Like, let's say here this is running, right? And if you think about those vibrations, create, shape, sphere. Let's make it small. Make it like a marble. And then we're going to take it, add physics, rigid body with colliders. So, I mean, it all interacts, right?
Mm-hmm.
So my thought there is, if you just, if you think of this as a vibrator, is that what you call it? Shaker. And if you make this a shaker, you can just make this arm short and you could make a shaker. I know you could do that part. And then if you put marbles and stuff into it, it seems like it would, I just don't know how, oh, that's our convex hull collision bounding box going on there. But
Well,
be worth a shot. I'm really curious.
let's do it.
All right, let's get rid of that. Let's drive this joint so we can wrap this up. Let me see here. All right. Let's go to our joints. Physics, no. Where are the joints? Right here. So let's go to the ground crank joint. And if we look at this joint, if we go to the Revolute joint advanced, no, where is it? Well, I think we have to add it. Add physics angular drive. Here's the drive. Type force, sure. No limited force. Target velocity. Let's just make it 100. See what happens. You're struggling, huh? Let's make it 1,000. There's a trick to this. I've already forgotten it. It's not going, I mean, it's kind of just creeping along, right?
It's going super slow.
Yeah. Let's make this number huge and see what happens. All right.
Okay. It's so fast, you can't see it.
It's still slow, right?
There's not like a super strong friction on there, right?
No. I don't think so. I think the friction is just 0. We could add a physics material to be sure, but the thing about it is, if I do this, so now it's going.
Seems like it's kind of constant. It doesn't seem like it's increasing or decreasing.
Get it go faster. Yeah. Interesting. If I remember right, it helps to add some stiffness to the joint or something like that. Let's see. Crank link, ground crank, crank. Because you can add joint friction is 0. Maximum velocity, joint velocity is big.
Does it need like an acceleration?
Where's that? Here's the drive. Well, it can be target position, target velocity, type acceleration. She's just not starting though for some reason. I think it's just going. If I make it force, I clear this to make it like target position, will it do that? No, it's not working. So it's not working at all right now. If I remember right, you have to add some stiffness to the joint or else it doesn't work or something like that. Let's just try it, just getting a stiffness of 1. Because notice that that's the drive.
So Zia asked, actually, the shift plus drag is the starting acceleration, right?
Yeah, that's just me making it go. You can grab stuff and apply it, force to it. You can see I can probably make it go backwards.
So, yeah, it's a way to add manually rather than through the simulation.
So something's not right with this thing. Oh, joint friction. I think you need maybe, let's just try. I just remember there was one of these settings where you're like, oh, now it worked. So I give it a tiny bit of friction. I'm going to give it a target position. And what I should do here, is it should just like go straight to that position, you know?
So what's the position in relation to?
From 0. So that's 0. So that's, I'm trying to put it at 45 degrees.
Oh, I see. Okay.
Yeah. Just going to give it, oh, the stiffness is, I'm going to give them these all small numbers. I'm going to give them these small numbers just so that some kind of zeros are bad news, you know?
And we only need to really connect one of the joints up with the force and not all of them?
Yeah, it's just going to drive. It's like putting a motor on that revolute joint.
Okay.
So what I'm going to do here is let's just clear this out. Oh, revolute joint, y-axis, no limits. So I'm going to save this scene. With that drive onto it. And then what I'm going to do is I'm going to go window. I'm in code now. I'm going to be in create here. Create's got some, it's got these demo scenes that are really cool. What's it code? I always forget. Maybe it's got funded.
I think either one, you can still open them up.
Oh, should have done that then.
It's just whether or not the extension has been enabled for that one.
So I go to window simulation demo scenes. There's a lot of good stuff in here. If I go to joints, distance, joints, break, joints.
Revolute.
Load scene. See, this one's got a drive on it, right? It just went. So let's see how they rig this up. Let's look at the revolute joint. Oops. It doesn't have any, it has an upper and lower limit. It's got a drive on it. Wow, look at that damping.
Interesting.
So if I do this, I'm just going to run on the damping. Let's see if it speeds up. Oh, hello. Look at that. Without enough damping, it just didn't work.
Did gravity beat it?
Yeah. So you should go faster now. Yeah, right? Okay. So we need a pretty big damping value.
Interesting.
I would not have guessed that. But let's try that and see if it fixes it.
Yeah, because we're not going up, right? We're just doing side to side.
Yeah, right. I don't understand, to be honest. Let's see if we can get it to go though. I just want it to work, guys. Let's see, geometry, joints, right here. Got that angular drive. Let's make that 50. Make that big. Okay.
Why?
Why? I don't know.
Huh.
Let's make that target velocity high now. Oh yeah, let's see what happens.
Oh. Oh.
Yeah, it just needs that damping or it doesn't work. Let's just fiddle with this. Let's give it a damping of 1 and see what happens. Look at that. It's slow. It's starting up slower with a with a lower damping. I wonder if this is like inverse damping. Because look at this. If I go 0.1 and run it,
So what is
look how
damping?
slow it's going. Yeah, it's a great question. Okay, and my hunch, and I need to verify this, but I'm guessing this is actually inverse damping. And if we make this really high, it's just gonna go almost instantly. That's my hunch. So okay, what is damping though? Um, so if you think of it as start with a spring force, right? So if you um, um, when you compress a spring, the more you compress it, the harder it pushes back, right?
Mm-hmm.
Damping, where a spring is related to position, damping is related to velocity. So with damping, the faster you move something, the harder the damping pushes back. And so if you move, so like you think if you were moving your hand through oil, through a big vat of thick or like glue. If you move your hand really slow, the glue's not going to push back much at all, right?
Mm-hmm.
But if you move your hand fast, that glue is going to resist a lot, and that is damping.
So it's like friction.
Yeah, it just pushes back. So like
Interesting.
with a spring pushes back, and the more you compress a spring, the harder it pushes back.
Mm.
And damping, it pushes back, but it doesn't have to do with position at all. It has to do with how fast. So the faster you move, um, then the harder it pushes back. That's why your cars have a spring and a damper. It's got a spring and a shock at each corner. That way, if your wheel's going too fast, that damper will slow it down and keep it from vibrating or shaking.
I see. So then in this case, we made the damping like this extremely large number here.
Right. But it made it go quicker, right? So it's like no resistance at all. Or if I make this really small, this damping number really small,
Then it won't move.
it's like it's moving through really thick glue now. It's not even moving. Is it moving at
Interesting.
all? Yeah, so let's go. Let's just see what we can get to move.
I see. So that's what you were talking about when you were like, this might be a reverse dampening.
Yeah, it's 1 over the damping. There we go. Look how slow that's going. So my hunch is that's 1 over the damping, really. And so a
Interesting.
damping of 0 is infinite damping, and it won't let the joint move.
Oh, because 1/0 is not defined.
But it's not actually the damping of the joint; it's the damping of the drive. I got to reach out and figure this out. So, but
Huh.
yeah, but the short answer is it. A really small damping number is going to make your joint not drive. Or a really big damping number is going to really make it drive, like immediately, right? So yeah, in 0, it's not going to drive at all. But the interesting thing is there's no damping on the joint itself because I can make it go.
Interesting.
If you look at this Revolut joint, there's a damping number here. So if I make that number 10 and that one huge, I bet let's eventually make this number big. That's going to add damping to it. I don't know.
What if you made it really small instead?
This one?
Mm-hmm.
Oh, maybe. It should stop pretty much. No, the joint damping isn't really working for me. So I'll dig into that a bit more. But I think once again, to get these drives to work, you got to add a damping value. Then it'll work. Oh, look at that. What happens when we do a negative damping value? Okay, 0.
Not allowed to. Oh man, there's some interesting questions in here.
Yeah. Oh, okay. All right. So Zia says the faster we move our hand through the glue, the more pressure we get. That's right. That's kind of how damping works. And how can we represent this in Python code and hopefully as a state space? So I think you're thinking of like, how can you represent the spring damper system like as almost like as the partial differential equation, or as a dynamic, as like a uh, spring damper kind of polynomial? Is that kind of what you're asking about? Small damping plus high force is equal to, yeah, I'm a bit confused by that myself because, I mean, the damping isn't quite working the way I expect. So I would want to dig into that some more and find out, because I can talk to internal people and say, like, how's this actually coded in the background, right? How does this actually work?
Mm-hmm.
And I think that would be worthwhile because it would be nice, like, if as an engineer, it would be nice to understand, like, what this damping actually is mathematically.
Mm-hmm.
Yeah.
Well, if it has partial differential equations, I will be hiding in a corner.
Yeah.
I did not enjoy that course at all.
Well, the good news with mass dampers is you end up with this polynomial that you can kind of. They've so many people have solved those differential equations that you don't have to solve them yourself.
Well, unless you go to college and you decide to take Calc 5 and they're like, guess what? You got to prove it. And you're like, no.
Yeah, we're not mathematicians. We're engineers. Come on. You can create prims in Python with USD bindings and create the physics scene, create the joints, link the joints to the USD prims, and then you're golden. Yeah, absolutely, Marco. You can absolutely do that. The thing that I think we don't understand is, if we want to actually model like the dynamics, how does that model relate to the numbers that we're putting in here mathematically? And that's not really clear to me.
What's
Because if I have like let me see if I can come up with a spring damper. This stay space. Yeah, not seeing a real clear one, but spring damper characteristic polynomial. Oh yeah, mass damper. There we go. And so what you're going to end up with is these, like, if you were an engineer, you'd be looking at a function like this with these with these. I know they're kind of like gobbledygook looking, but you've got these coefficients. And if you were an engineer, you'd be like, oh yeah, my damping coefficient is blah blah blah, and you'd want to be able to come into Omniverse and put that coefficient in, and you'd want it to behave like and simulate like your real spring damper. That'd be really useful, and I really think that would be a great. If you could combine, a sublayer. Let's say someone created a mass damper with the tree structure that you designate, what you could do is you could create a sublayer that if they bring it into their scene, it will add all of the joints and all of the frictions and all of the dampings and stuff to that spring damper system. And then you could write an extension so they enter their coefficients and it edits the dampings and all those attributes to give you the correct simulation. That'd be another really cool extension idea, in my opinion. So I think that's, yeah, I think that'd be awesome. Well, we're over time, but I was having fun. So lively discussion. And I look forward to meeting with everyone next week. So I feel like we've got this where we need it to be. I will look into some of those questions of like, how does this damping really work? How does it relate to the actual mathematical equations and the physics in the background? And I'll ask around a bit. But starting next week, we're going to go back to writing an extension. And before we were on the official channels, we were working on an extension to do some data acquisition on this thing. And the end goal is we want to capture a load case on this crank arm so that we can run it through topology optimization and reduce its weight. But to do that, we're going to use Omniverse to capture load cases. So the next step is we want to add some accelerometers to this thing. We want to add some data acquisition so we can capture those loads. It should be fun. And so until next time, we'll see you later.